Hello students, welcome to Spectra Education Academy. In this video, I am continuing explanation for the remaining short answer type questions from the chapter Moving Charges and Magnetism. Let us continue. Question is, derive an expression for the magnetic induction at a point on the axis of a current carrying coil using Biot Savart law. So current carrying circular coil. So let us draw like this. This is current carrying circular coil in the vertical plane. It is carrying current I. It is carrying current I, maybe clockwise or anti-clockwise. Say this is current. So take a small element whose length is dl. Now let us say this is the center of the circular coil. The question is to find out magnetic field induction at a point on the axis. So this is say axis, this is the point. This is the observed point of P. Now let us draw a line which is joining the element of length dl and point P. So it is called R. So therefore, this is the radius of the circular coil. This is center O. This is the radius of the circular coil. Now take this as circular coil carrying current I. So it definitely forms magnetic field around it. Now let us say at this particular point, magnetic field will be magnetic field because this particular point is in the space. Magnetic field will fall in the plane, XY plane. So let us say this is dB. So for this dB, there will be two components. This is dBy, vertical component. This is dBx, but along the axis, we continue with dBx. Suppose if this is pi given, automatically this also will become pi. So this is horizontal component. This will be dB cos theta because dB is resolved into two components. This is dB cos pi and this will be dBx. Horizontal component, this is dB sin pi. Now get back Biot-Savart law, mathematical form of Biot-Savart law. So it is dB is equal to mu naught I into dl sin pi divided by r square. If you remove sign, you can express in terms of position vector. This is vector form of Biot-Savart law. Mu naught I dl cross r cap divided by r square. So you know that unit vector as r bar by mod r. So keeping this in mind, you can write that mu into I dl r bar by r square, this r bar by mod r. So it will be mu naught I dl r bar divided by r cube. If you remove cross, you will get the sin pi because on removal of cross product between position vector and dl, you will get sin pi. So this is all dB is equal to mu naught I dl r sin pi divided by r cube. So again you will get r square. So therefore, if angle is pi is 90 between the position vector and the element is 90, what you can write dB as? dB is equal to mu naught I dl divided by r square. Now, so this is equation 1. Now, at the observed point, we are looking for the equation for the magnetic induction. So that we are going to with dBx. dBx is written as dB sin pi. Now, so what is dB is here is mu naught I dl divided by r square along with the sin pi. Now let us integrate this. Before we integrate, let us write from the diagram sin pi as sin pi is equal to opposite by hypotenuse. What is opposite? Radius of the circular coil will be opposite. Hypotenuse will be r. So let us write that first. So mu naught I divided by r square. Sin pi is r by opposite by hypotenuse. Let us integrate this one dl. This is equal to dV. So this will get B. Now, integration of this. Integration of this will be dl, integration limits will be 0 to 2 pi r, because element can be taken along the circumference of the circle at any point. Mu naught I. Now divided by r cube. This is going to be dl, integration is L. After that, in place of L, you can write you can substitute the limits. This is 2 pi r, because circumference radius of the circle we took it as capital R. So altogether this will be, yeah, so we missed one point here. Everywhere there will be mu naught by 4 pi. Yeah, so this is going to be 4 pi. This is also going to be 4 pi. Even here also going to be 4 pi. Now, it is already there is r. So mu naught I by 4 pi r cube, r square into r cube, 2 pi r into r. This is r, 2 pi r limit. So therefore, mu naught by 4 pi I into 2 pi r square divided by, what is r here in the diagram? R can be written as hypotenuse. It is, let us say this is x. So r can be written as r square plus x square. Now you can write this r cube as, r is root over r square plus x square, but there is cube. So in simple form you can write that mu naught I with 2 pi r cube divided by 4 pi r square plus x square 3 by 2. So x is the distance from the center to the observed point. So this is the desired equation. Now let us continue another question. A circular coil of wire consisting of 100 turns, each turn of radius 8 centimeters, carrying current of 0.4 amperes. What is the magnitude of the field at the center? So just now we got one equation. Center means x is 0. So same equation, let us write B equal to, this is question number 6. B is equal to mu naught I 2 pi r square divided by 4 pi into r square plus x square whole to the power of 3 by 2. So they mentioned that at the center means x will be 0. So this particular equation will become as mu naught I 2 pi r square divided by 4 pi r square to the power of 3 by 2. It will be 2 and 2 get cancelled. So you'll remain with mu naught I 2 pi r square. If n turns are given, so every turn will have its field at the observed point. Mu naught I 2 pi r square into n. Even here also you can write that. Here also you can write that. Then 4 pi r cube. So therefore r square and r cube cancelled. Pi get cancelled. 2 2s are. So therefore finally we get mu naught I into n by 2r. So now let us substitute the values given. Mu naught is 4 pi into 10 to the power of minus 7. I is 0.4 divided by 2 into r is 8 centimeters. And number of turns, this is current number of turns are 100. And radius is 8 centimeters. So 8 centimeter, conversion of centimeter into meters. So now cancelling, this is going to be minus 5. And this is going to be 4. This is going to be 2 2s. This is going to be 2 4s. This is 1 time. So finally we get that this is pi value is 22 by 7, or roughly you can write this is 3.14 into 10 to the power of minus 5. With there is a 10 here into 10. So this is going to be 31.4 into 10 to the power of minus 5. So unit of magnetic field will be Tesla. Students, let us continue the last question, that is seventh question. Question is, derive an expression for the magnetic dipole moment of a revolving electron. So dipole moment is generally expressed with capital M. Now consider an electron. So this is how you need to express. Consider an electron revolving in the circular path of radius r with frequency f, while electron moving in the circular path. Electron moving in the circular path, after completion of every revolution. After completion of every revolution, it travels a distance. Is equal to circumference, that is equals to 2 pi r. Now time taken to complete one revolution. So t equal to distance by velocity. So this distance is equal to circumference. This is going to be 2 pi r divided by v. When charge moves in the circular path, the current produced due to the motion of the charge in the circular path is equal to, since it is q by t, but now charge is electron by t. So this is the rate of flow of charge. Call this is equation 2. This is equation 1. From this we can write t equal to, in place of t we can substitute that 2 pi r by v is equal to E by I. Now we can write that from Biot-Savart law, magnetic moment due to revolving electron in the circular path is given by I into E. So this is one of the application of Biot-Savart law. Area of the circular coil is I and area of the circular coil is pi r square. Now from this equation we can write that I is equal to EV by 2 pi r. Let us substitute this part here. IV as EV by 2 pi r into pi r square. So therefore, 1 r get cancelled, pi get cancelled. So therefore, the magnetic moment equation for the revolving electron is EVR by 2. So we'll get even the angular momentum also if you multiply and divide with m. So MVR, E into MVR. MVR is angular momentum by 2m. So, but of course, we can write up to here only, this step only, EVR by m. Up to here only we need to write for IPE. Thank you very much, students, for watching my video. But don't forget to share and subscribe with your friends and relatives. Thank you very much.